Okay, welcome everybody to our second session of the afternoon technology track. I'd like to introduce to you all Bahram Sadighian from Mitra Aerospace, who's going to talk about horizontal takeoff and landing rockets. So thanks again for coming to attend. Turn over to you. Thank you.
Hello. I'm here to talk about these two devices here, and basically, hopefully, if we put them together, we might be able to do much easier travel procedures from Earth to low Earth orbit. Wouldn't it be nice if we could go to a local airport and get into what I call an aero-spacecraft and go to low Earth orbit, finish the assignment, whatever it is, and come back and return to an airport. Any airport, no gliding, no parachute, a powered return. And that's basically what we need to do to make sure that when we do our experimental proof of concept travel to Mars orbit, we don't end up parking the ships and the mission doesn't end up as a science project. So we need to be able to do something right after that mission is done to make sure that we are headed that way. So and I think the only way to do that is we need to have a more regular and actually a basic regular presence at the low Earth orbit. So so as I said, frequent deep space travel needs massive infrastructure, both at low Earth orbit and in the ground. And this infrastructure could be placed only if we can travel several missions per month, per week. And these launches need to be made from anywhere on the planet. Right now, we can only launch from specific places. And there is a lot of ground transportation involved in getting everything to one place and go there. So if we could manage to fly from a local airport to low Earth orbit, then most of the ground infrastructure is already in place. We have hundreds of 11,000 feet runways all over the planet, and they are all located near industrial areas and business areas. And that would be about 90% of the ground infrastructure. Looking at the vertical, the conventional vertical rocket launch right now, I have to say that in the future, all the launches will be vertical takeoff and landing. But with this propulsion system that what we have now, the chemical propulsion, the vertical launch landing is only good maybe for Mars. When we go, there is no runway. But here, we need something more repeatable at a better cost. So these vertical launches so far, what we have right now, they can only be conducted from specific locations on Earth, and does not allow for any load return capability to Earth. If we are putting massive infrastructure in low Earth orbit, there will be a return payload requirement at one point. If it is not cargo, it's definitely crew. So, and we definitely would like to return more than 4 or 6 people at a time, because there will be a large crew working up there. And so the vertical launches are basically mostly right now they're expensive disposable systems that cannot support a serious business operation up there. And it cannot be presented to the investing industries as a launch system that allows them to go to space and run a space-based business. So, and besides, once we have a good infrastructure in low Earth orbit, we can attract more business up there. And it will support whatever else that we are planning to do there. And one of them is definitely putting together large ships for travel to Mars and increase the number of the people that we are sending there. So, as I said, once it's done from the runways, now we have frequent travel to the orbit, and that will allow us to think about larger crews to send to Mars. That will definitely ensure the success of the mission. The problem with the long-term space travel is that crew of 4, it's at least 2 years of space travel. So if, anything could happen. But once we send a large group to 200, 300, 400 people there, we are sending a small society with physicians, with dentists, with everything that is needed, and healthy crew is ensures they can deal with any kind of situation that might come up. But unhealthy crew could actually start some situation, and it is a long way travel. So I'm definitely for sending more large spaceship groups up there. And again, once we have the infrastructure in the orbit, then we can start assembling more ships together. And and then also, as I said, it will bring more business. Once we have the infrastructure, then we can start taking the possible investors and the industries up there and show them what we have up there, and bring more interest to the operation. And it also creates other businesses up there, like suborbital travel. Suborbital travel would be something that definitely bring money to the operation. And so for suborbital travel, we definitely have airliners, and for space tourism, we definitely have all the hotel chains that they will come up there. So the system itself is what I call an aero-spacecraft. And this aero-spacecraft is definitely has to have a different kind of propulsion system. And this system actually the main goal is to increase the reliability of the two most major components, which are the aerospacecraft and the engines. So it doesn't have to be, it has to be conducted like an airline service, which I would like to call it the space line service. And what we could do, I think we have all the technologies, off-the-shelf technologies and proven technology to put together and put the propulsion system together. And as a model for the aerospacecraft itself, we could, space shuttle would be a very good example. I mean, his in-atmosphere flight has never had any incidents, excellent glider, and all we have to do to replace the 3 engines in the back with a different propulsion system. Or this is only a concept of what we're talking about, but a space shuttle itself is really a very good example for that size of load. So the aerospacecraft will be able to launch, to take off from 11,000 feet runway, go to 50,000 feet, and after that start the rocket engines and go to the whatever orbit it has to go. And of course, the big advantage of that is there will be no gliding, no parachute if we land at any airport. Right now, if we decide to bring public's attention to space travel to them, is basically a fiery takeoff, and then the return is a parachute, and then the helicopter is basically a fiery takeoff and a massive rescue mission. It is not travel to them. That's what it is. So the propulsion system itself, if we could put it together, it would be, I think it is not really that difficult anyway. Is basically a ducted fan system backed by a rocket engine. And the way we came up with the idea was, let's say we decide what kind of a load, what size of a load we are planning to rocket from 50,000 feet to whatever orbit that we want to go. And after that, we have to design the fan system that could propel the entire weight from the ground to 50,000 feet, and that includes weight of everything, and return fuel, of course. And then we can, size the engine, size the fan around the rocket engine. The ideal situation is to use an existing rocket design, which these days are available at the SpaceX or Blue Origin, and they are reusable. The ideal situation would have been if we could just use an existing fan system and an existing rocket system and try to put them together. But the fan system might be a little problem. The rocket, we don't have to do much. It's done for space travel. The fan system, it employs the regular, the low pressure compressor, the high pressure compressor, and the combustion chamber, and then the high pressure turbine and low pressure turbine. This may not work for repeated travel to space because of the severe temperature changes that we have on the material, and these material had never been tested in space. So we have to look at other options for the fan operation. And one of the options that I'm looking at is blade tip propulsion. And a few years back, there was a company, Rotary Rocket, and they had but it was a very large scale. So we were thinking maybe we could employ that blade tip propulsion and use it in a fan. And some research has been going on in NASA for magnetically levitated ducted fan, which it's great if it could be done because it is electric powered and clean. If not as complicated as it sounds, but a blade tip propulsion might be a good option, even if you have to use jet fuel and liquid oxygen. So jet fuel is again available at any airport. So what we have to do for these launches, we just need new facilities for liquid oxygen. And as I said, trying to avoid compressors and turbines and go to blade tip propulsion. And as a rocket engine, we don't have to do anything to rocket engine. It's available. And fan operation, that's what we are working on. And it depends into the size of the mission, to the size of the payload, and to the orbit that you're going. We can go different ways to propel the blades. And as I said, the shuttle is a really, really, really good example of the retired space shuttle is a very good example of what we have in mind. As I said, is a good in-atmosphere flight, and has a 22-ton capacity. But for the beginning, it might be a little too heavy to start with. So for the beginning, I would really would concentrate on just a crew transfer on a smaller loads, and see if we can put the system together. And if we have to go and build something about the size of a space shuttle, is 80s technology. It would be about 50% lighter nowadays, which provides more more weight for fuel and cargo, and replacing the 3 rockets in the back with a ducted fan system and possible smaller rockets on the back. It doesn't change do much on the aerodynamics. And if we do add front wings to the system, it might allow us to do a slow re-entry and avoid hypersonics, I hope, because I think eventually we might be able to put the propulsion system together, but the return travel at Mach 27 and the heat shield is still going to be an issue that we have to deal with. So basically that's all I had to say about this, and I myself am basically mostly in the business part of this, and but I will answer any questions if I can. Yes.
You mentioned the space shuttle a lot, but the space shuttle, in fact, that was required to bring us back to flight status after each flight. So getting up to low Earth orbit is one thing, but the reentry parts really still haven't been solved without tiles or without an ablative shield, which is very expensive.
Yes, it is. That's the, as I said, we might be able to solve the propulsion, but reentry at 100%. Still a problem.
Have any thoughts on this matter of like to ever do horizontal reentry?
Well, a spaceship 2 by Scale Composite, they are returning with by feathering the front, the aircraft.
Slow speed.
Yeah, it is very low speed, and also the orbit is only 68 miles. But if we are going any higher, then it's going to be a little more difficult. We have no way to avoid the hypersonic return. So yes, the heat shield is still an issue that we need to deal with. Yeah, but the propulsion itself is doable. So a propulsion system, I think this size, as I said, it definitely work with something like the size of a spaceship 2 for 6 to 8 person crew. And it could also be extended for a little higher orbit. We are looking at it.
I was going to ask you about the lighter weight and anything you might be able to say about composites as a percentage of its structure.
At the percentage of the structure, as I say, it is really in the concept stage right now, but I look around and I see, again, I have to use the spaceship 2 example. I think it's only 7,500 pounds empty weight. So it is very light. So yes, the composite materials, yes, of course.
What's the target velocity at 50,000 feet, and what mass fraction is required in there?
Well, as I said, it all depends on the weight and orbit that you're going. As I said, and we are on the conceptual stage. Right now, we are basically looking at see if we can put we are examining the idea of putting the ducted fan system and the rocket system together, and get a little more detail on that. What can we do to avoid the combustion chamber and things like that? What kind of velocities or speeds I can achieve with those new systems? We don't know that yet. But
So if you're looking at the business case, what are you talking about? Cost
cost.
per pound to orbit, and how soon is this going to happen?
Right now it is about $10,000 per pound to 268 miles, I guess. So how soon is it going to happen is how soon we can put everything together, and how much the cost will be. I'm hoping to bring it, even if we bring it down to half, then it's an achievement. And even if we don't bring it down to half, it is still at $10,000 per pound, but we can do it more often, then we have a different economics to deal with. So the cost may not change that much, because at the present time, we are looking at fuel is not the expensive part of this operation, any space operation. But once we start doing it more often, then fuel will become a big part of the operation. And the good thing about having a rocket-powered ducted fan is because of the fact that a jet engine has uses the air to use as an oxidizer, then the savings will start there, and not in one flight, but in hundreds of flights that we will do. So we will save a lot of money from ground level to maybe 50,000 feet, maybe 80,000 feet, and once these flights are done in numbers, then the savings are big. But cost could be, we don't know, I could say $10,000 now, but 10 years from now, when we make that happen, it still could be more.
So what's the maximum velocity of your ducted fan?
The maximum velocity achieved by the ducted fan, meaning,
Subsonic, supersonic?
oh no, it's definitely subsonic to 50,000 feet. Yeah.
Question? Without a compressor and turbine, how do you power the ducted fan? What powers it?
I was thinking about blade tip propulsion. Yeah. So that's something that we're studying right now, and I don't have anything to show you right now, but we are working on some samples. But we will start posting pictures and results in about maybe every 3 months on the website. Go ahead.
Yeah, I think people will be skeptical because you're investing $10,000 a pound to bring your ducted fan to orbit, and just the same problem with bringing wings to orbit. Unless you really need that in orbit, well, why bring it? Leave that behind in an air environment first stage.
Will you please?
Well, I think you're wasting most of your potential payload by bringing the engine to orbit.
Well, but
You must have done the numbers.
I know, but the entire effort is to make sure that we are not traveling back by parachute or gliding. So this is something that needs to be done one way or another, and we are looking at it. Otherwise, we won't be able to make that many trips that is required to do anything major.
I think he's considering the benefit of this over the Virgin Galactic method. What benefits would this method have over using conventional airplanes to carry it up to the height and then dropping it and igniting the rocket? What is the benefit of this system?
Oh, the benefit of this system is, first of all, it will take off under its own power from the runway, and on the return flight, it is a powered flight. You can go to any airport. You have several, I mean, we can go to any airport. Yes, and so the fuel being Jet A, a kerosene-based fuel, it will do a lot for us before it becomes fuel, and also in coming back, it's jet fuel that could be used. And
I'm not sure, but to clarify what the other person asked, not so much that it's a non-reusable second stage, but to separate the turbine-powered from a large mothership, which would be very conventional, and then have a winged body to orbit with just the rocket. So instead of carrying the engines and having that complexity, have a mothership that would then allow a smaller orbiter to go up, and then it would have, or let's say it would have an engine that could be started. It wouldn't need, all the extra paraphernalia.
yeah, yes, of course. I mean, it all depends which way, how well we can put the system together, especially the propulsion system. It will be the propulsion system that will tell us what we can do or what we cannot do. Thank you.
Thank you very much.
Thanks.